Good afternoon, evening, morning, night, day, Charger family. This is Mrs. Boyd and Mrs. Boyd's Math Room. Thank you for joining me today for, I'm marked, writing equations. This is part 2 where we talk about consecutive integers. Let me erase whatever this ridiculousness is that I put down here. Sorry about that. Oh, Lord, it's already started. Okay, here we go. So we've already talked about writing equations. We've already talked about solving multi-step equations. So today we're going to write equations with consecutive integers, and we're going to solve them all at the same time. Dog's coughing. Don't mind him. All right. If we're going to write about consecutive integers, oh, Lord. We first need to know what consecutive integers are. Consecutive integers are like counting numbers. That's an M. My computer disagreed. So 1, 2, 3, etc. are counting numbers. Okay. So find the 3 consecutive integers whose sum is 123. Well, if 1 is n, so we're going to let n equal the first integer. Then 2, we add 1 to get from 1 to 2. So 2 is n plus 1. So n plus 1 is the second integer. And then we add 1 again. So 3 is n plus 1 plus 1, or n plus 2 is the third integer. So we've got the first integer, the second integer, and the third integer, and their sum is 123. So when we combine like terms, what we need to do first, when we combine like terms, we have to combine everything that is exactly the same. So the n's are all exactly the same, and the constants are exactly the same. They're on the same side of the equals, so we just do what they say. N plus n plus n is 3n. 1 plus 2 is plus 3, and that equals 123. Now, we know how to solve this. We want to get 3n alone, so we'll subtract 3 from each side. And we have 3n is, 3's cancel, 120. Then to get n alone, we divide everything by 3, and we've got n is 40. Well, that means n is 40. 40 is the first of the 3 consecutive integers. So our counting numbers are going to be 40, 41, and 42. n plus 1, and n plus 2. Let's add these together and make sure their sum is 123. So 2 plus 1 is 3, 4 and 4 and 4 is 12. And that is indeed correct. So these numbers are the 3 consecutive integers whose sum is 123. Let's try another one. Now we want to know the first 4 consecutive integers whose sum is negative 62. So we already know that our first 3, n is the first integer, n plus 1 is the second, n plus 2 is the third. I bet you can guess what the fourth is. N plus 3 is the fourth integer. So we add all these together, n plus 1, plus n plus 2, plus n plus 3, and their sum is negative 62. Well, again, we want to put all of the n's together and all of the constants together. So we've got 4n plus 3, 4, 5, 6 is negative 62. So to solve, we've got to subtract 6 first. And we get 4n. 6's cancel is negative 68. Then we can divide by 4 on both sides. And we get n is negative 17. So that's our first integer. We also have, if we add 1, negative 16, negative 15, and negative 14. Let's add those up and make sure they add up to negative 62. 13, 18, and 22. 1, 2, 3, 4, 5, 6. Negative 62. We've done it. So those are 4 consecutive integers whose sum is negative 62. That's how we're going to do all consecutive integer problems. But now we're going to look at consecutive even integers. These are counting numbers as well, but evens 2, 4, 6, 8, etc. So if your first integer is n, we have to add 2 to that to get to 4. So 4 is going to be n plus 2. So we know we're going to let our first integer be n. So that looks like the first 3 consecutive even integers whose sum is 72. So we need 3 integers. We know the second integer is going to be n plus 2. And then to get from 4 to 6 here, we add 2 again. So 6 is n plus 2 plus 2, or the third integer is n plus 4. So we're going to add all these together. N plus 2 plus n plus 4. Their sum is 72. Put the constants and the variables together. 3n plus 6 is 72. We got to subtract 6 to get n alone. 3n is 68. No. 66. Then we divide by 3, and n is 22. So that's our first consecutive even integer. The next one, don't forget these are even, it's going to be 24, and then 26. These all need to add up to 72. So let's see, 10, 11, 12, 2, 4, 6, 7. Yep, looks like we've done it. 3 consecutive even integers whose sum is 72. Another one just like this. 2 consecutive even integers. Well, we can use the same info from the first one. We're going to let the first integer equal n, and then the second one integer is n plus 2, and their sum is negative 118. So n plus n plus 2 is negative 118. Add the variables. No constants to add. There's just 1. So n plus 2 is negative 118. Subtract 2 from each side. We get n is negative 120. Well, if that's one integer, one even integer. Oh, I made a mistake. I hope you see it, because I missed it, obviously. This should be 2n plus 2. So now I divide by 2. We got n is negative 60. Whew. So our consecutive integer is negative 60. They're even, so the next one is not 62. Holy mackerel. negative 58. So we can add these up and we get negative 118, which is exactly what it was supposed to be. So negative 60 and negative 58 are two consecutive even integers whose sum is negative 118. Surprisingly, the odd integers work exactly like the evens. These are odd counting numbers starting at 1, 1, 3, 5, 7, and so on. Find three consecutive odd integers whose sum is 117. Well, if we let n be the first integer, then the second integer is, to get from 1 to 3, we do plus 2. So the second one's n plus 2. From 3 to 5, that's plus 2 more. So the third is n plus 4. So we want to add these up, n plus 2 plus n plus 4, and their sum is 117. We can add all the variables and all the constants. I'll try hard to do it right this time. 3n plus 6 is 117. So we subtract 6 from each side, and we get 3n equals 111. We divide both sides by 3. We get n is 37. I think so. So it's our first odd integer. We went 3 in a row. So 37, 39, and 41. Let's add them up. 16, 17, 4, 5, 6, 7, 8, 9, 10, 11. We've wrote right through it. 37, 39, and 41 are the three winners. Same idea for the next one. 4 consecutive odd integers. So we use the first 3 from the last problem. So we've got n and n plus 2 and n plus 4. And then the fourth, we're going to add another 2 on, n plus 6. So the sum of all these sorry, the dog's going to bark, is negative 328. So we're going to add up the variables. There's 4 of them this time. And the constants. So we've got 4n plus 12 is negative 328. Subtract 12 from each side. And we get 4n equals negative 340. We can divide both sides by 4. We get n is negative 85. I'm going to get my calculator out for that one and check my work. Oh, I'm right. So the first of our consecutive odd integers is negative 85. Then we need 3 more. So negative 83, negative 81, and negative 79. We can add these puppies up. That's 18. 3 times 8 is 24, and 7 is 31. 32. So we've done that one again. All right, these are a little bit confusing, but I'm sure you can do it. Just follow the same pattern. I've given you all of the structure that you need to be successful on these problems. Let me know if you have any trouble. I look forward to seeing you soon.